Today's objective is to be able to create equivalent expressions by using the distributive property. Throughout this unit, we're going to be looking at expressions that will look different but essentially still have the same value. So for example, if I gave you 2 parentheses 3 plus 5 and also gave you 2 parentheses 3 plus 2 parentheses 5, these two expressions look different, but we will see that they actually have the same value. This green expression here, 2 parentheses 3 plus 5, tells me, well, add 3 plus 5, which will give you 8, and then take that and multiply it by 2 to then give you 16. Now this red expression here tells me, well, we're going to do it a little different. We're going to first do 2 times 3, which gives me 6. Then we're going to do 2 times 5, which gives me 10. And then we're going to go ahead and add those two things, which also give us a value of 16. So as you can see, these two expressions both looked different, but essentially they gave us the same exact answer back. Now, the property that allows us to do that allows us to simplify these two expressions in two different ways, is called a distributive property. And the distributive property tells us that if you multiply what's outside of a parentheses with everything that's inside of the parentheses separately, it'll still give you the same value of the expression back. So how do we use the distributive property with algebraic expressions, meaning expressions that have variables and numbers in them? So in example 1, we have 3 parentheses x plus 4. Now, first thing we must notice is that every time we see a number or a variable next to a parentheses, we are actually multiplying. So when I see this 3 over here and a parentheses right next to it, that means that I'm multiplying 3 with whatever it's inside of that parentheses. So here this is actually telling me take 3 and multiply it to x plus 4. However, given that x is a variable and 4 is a constant, they are not like terms. 4 does not have a variable, so I cannot combine those two things, or I cannot add them up to then multiply it by 3. Instead, I must use the distributive property to multiply 3 times x and 3 times 4 separately. So let's see what happens. First, I'm going to rewrite my expression so that they are coefficients next to any variable. So I have 3 parentheses 1x plus 4. Now, again, this is telling me take 3 and multiply it to everything that's inside of this parentheses. So I'm going to first take my 3 and I'm going to multiply it to this 1x. I'm going to distribute it to this 1x. Now, throughout algebra, you're going to see me use these little arrows to signify that I'm distributing or multiplying what's outside of the parentheses with what's inside of the parentheses. So first I have 3 times 1x, because again, anytime I have a number next to a parentheses, that's multiplication. Now I'm going to separately take this 3 and I am now going to distribute it or multiply it with this positive 4 that I have here. So now I have 3 multiply with positive 4. And usually when we don't have when we have a positive number, we don't have to write the plus sign, but I'm writing it there so that we know that it's a positive number and not a negative one. So now I'm going to multiply these two pieces separately and see what I get when I do that. So I have 3 times 1x. In order to multiply this, I'm going to multiply the 3 with the 1. So 3 times 1 gives me 3, which means this is 3x. And now when I multiply 3 times positive 4, that's going to give me positive 12. Because again, if I do 3 times 4 on my calculator, that's just a 12 or a positive 12. And I'm going to write that down as well. However, I can't just leave my answer like this and say, well, my answer is 3x and positive 12. I have to actually rewrite this as an expression together. So since 3x has a variable and positive 12 does not, again, I can't just say, okay, 3x plus 12 will give me 15x. That's not my answer. I'm just simply going to rewrite them next to each other. So I have 3x plus 12 as my final answer. So I've just created an equivalent expression, something that is equal to 3 parentheses x plus 4 by using the distributive property and multiplying the 3 to what's inside of the parentheses. But how can I check whether these two things are actually equivalent, or how can I check whether these two things whether my answer is actually correct. Well, in order to check, I can actually pick any number that I want for x, and I can plug it into both expressions and see that I get the exact same thing. So I'm going to pick any random number. I'm going to say x is equal to 1. And again, I'm just picking any number, it doesn't matter which one. And I'm going to first plug it into my answer. So I have 3 parentheses 1 plus 12. When I put this into my calculator, if I simplify it by hand, 3 times 1 is 3 and plus 12 gives me 15. And now I'm going to check when I plug in 1 into my original expression, if I get the same value. So if I do 3 parentheses 1 plus 4 and I put this into my calculator, you will see that this in fact gives me 15 as well, which means that I've done the correct work, and these two expressions are actually equivalent to one another. So here we have another example which is very similar, but now negatives are coming into play. So we just want to make sure that we're very careful when we're writing down our problems and when we're simplifying them so that we don't lose track of our negative signs. So now I have negative 2 parentheses 5x plus 3. So again, since I have a negative 2 right next to the parentheses and nothing in between, this is telling me that I need to take this negative 2 and multiply it with 5x plus 3. But just as in our first example, 5x has a variable and 3 does not, so I can't just simply add these two things up and then multiply them by negative 2. Instead, we're going to use our distributive property one more time and multiply our negative 2 with our 5x first, our negative 2 with our 3, and then put those two things together. So I'm going to go ahead and take this negative 2 because again we include the sign that comes before that number, in this case this negative that comes before the 2, and I'm going to distribute it to this positive 5x that I have here. So I have negative 2 times positive 5x. But then I'm going to take my negative 2 and I'm going to distribute that to this positive 3, again including that sign that I have here. So on the other side I have negative 2 times positive 3. So when I multiply negative 2 times 5x, negative 2 times 5 is negative 10, and make sure you're using your calculator to double check your multiplication. Even I mess up sometimes. So negative 2 times 5 is negative 10, so that's negative 10x. And negative 2 times positive 6, that's actually a negative 6, which I have here. So one piece of my distribution gave me negative 10x, and the other piece of my distribution gave me negative 6. And now all I have to do, again, since negative 10x as a variable and negative 6 does not, I can't combine them, so I'm simply just going to write them next to each other. So I have, as my final answer, I have negative 10x minus 6. Okay, that negative must be brought down with the 6. And that's my final answer. So again, this is not an equivalent expression that I've created, which should give me the same thing as negative 2, 5x plus 3. Again, if I want to check, I'm going to pick any random number. I'm simply just going to go in order here and pick 2. And I'm going to plug it in to make sure that it gives me the same exact thing. So when I plug it into my answer, I have negative 10, parentheses 2 minus 6. And you will see that if I plug this into the calculator and I evaluate it, this will give me a value of negative 26. Now if I check on the original expression, I have negative 2, parentheses 5, parentheses 2 plus 3. And again, if I evaluate this in my calculator, you will see that this will also give me a value of negative 26. So my expression, my original expression, and the one that I've gotten after I distributed are equivalent to each other. We have one last example here where we're still following the same steps, except that now we have a lot more negatives. So again, we continue to be careful with those negative signs and keeping track of them. So now this example, negative 4 parentheses negative x minus 6, again, since there's nothing between the negative 4 and the parentheses, I know that this is telling me to multiply the negative 4 with the rest of what's inside of the parentheses. But before I do anything, I'm going to rewrite it so that there is a coefficient next to every variable. And now I can go ahead and begin distributing. I'm going to take this negative 4 because we included symbol or its sign, and I'm going to distribute it to this negative 1x, again including the sign of that term. So I have negative 4 times negative 1x. And now I have negative 4 times negative 6. Now when I evaluate these things, negative 4 times negative 1 is a positive 4. Again, you want to double check by plugging this into your calculator. So you want to put negative 4 times negative 1. That's going to give you a positive 4, so that's positive 4x. And now negative 4 times negative 6, when I put this into my calculator, it's going to give me a positive 24. And since these are unlike terms, I cannot combine them, so I'm simply going to rewrite them next to each other. So 4x plus 24, which is equivalent, or should be equivalent if we did the right work, to negative 4 parentheses negative x minus 6. If I check, I'm just simply going to substitute in any value. I'm going to do 2 again. I'm going to say x is equal to 2. Again, you can pick anything anytime you're checking. 1, 2, 3, negative numbers, decimals, whatever you want. And I'm going to say 4, parentheses 2 plus 24. And that's going to give me a value of 32. When I plug this into my other expression, I get negative 4, parentheses negative 1 times 2 minus 6. And when I substitute this or evaluate this in my calculator, again, it'll give me a value of positive 32, which means our expressions are equivalent to each other. In your task, I want to make sure you show as much work as I'm showing. I'm not simply just writing my final answer. I'm showing the 2 things that are multiplying. Sometimes it might be 3 things that you're multiplying, but the process doesn't change. And then I want you to show me that you've checked for 2 of the problems that you'll be working on.